Hello, everyone, and good morning. Once again, back to the sessions on Python for data science. Today's topic is all about finishing up on numpy, which is what we started off yesterday. And then we will move on to continuing with pandas. And both numpy, you might have got some overview of numpy already yesterday, right? It's an important framework when it comes to numerical Python. It's an important framework when you have to manage arrays and you have to arrange them together in a specific way, etc. All that becomes very, very important when you're looking at numpy. And then we land up with something that's called as pandas. And pandas is kind of similar to numpy, but at the same time, not exactly similar to numpy. So pandas works differently, wherein it starts with you having something called as DataFrames. And DataFrames are nothing but a representation of an online table. So when you have your database tables and you want to load this data inside a data frame, or you have Excel sheets, you have CSV files, and you want to load them, that's where pandas comes in. So today we'll be doing both numpy and pandas. We'll be starting off with pandas, with the remaining parts of pandas, and then, the remaining part of numpy, and then proceeding on to pandas. So good morning, all of you, and welcome back into the session. Also, we've had some awesome submissions that came through for the 7 days to data science challenge. We're really mesmerized with the number of submissions. There are over 350 submissions in total, which is 350 unique concepts that have come in total. Our jury panel is going crazy evaluating all of these, and a lot of these submissions came closer to midnight yesterday. So we are still evaluating it, and they're literally going crazy. They've woken up early morning today just to make sure we evaluate it on time. And we promise you before 4 p.m., before we close for the day, we will have the winners of 7 days of data science challenge. So whether you win or not, congratulations to all of you. The very fact that you've done this critical thinking course in data science, you've now become what we call as AI thinkers, so you can now think AI, you can think machine learning, you can think data science. So it's a phenomenal achievement for all of you already, and we will be choosing the top 3 winners by end of today. So let's begin our journey again with numpy. Suvir, good morning to you. Welcome back. And are you ready to start?
Hello, Sanket. Good morning. Good morning, everyone.
Over to you, Suvir.
Sure. Thank you, Sanket, for that introduction. And I welcome everyone back into the session. I hope today is Sunday morning and we have some spirit to learn machine learning and continue with our sessions. Once again, thank you for joining on a weekend that is yesterday and today. I hope you're able to hear my voice well and loud and clear. I'm going to share my screen in just a moment. All right, guys. So I have shared the screen. I hope you're all able to see the screen. And we're going to continue with numpy. The only thing is that we have to be a little quick in the overview and the curriculum which we have today. So, so we'll try to finish up with numpy, which is left off from yesterday, and then we will go to our pandas. So as everyone knows, we are using numpy for numerical computations, correct? So what kind of computations? We looked at some of the basic operations on arrays. And I'm sure now everyone knows what is an array. And I'm also sure everyone knows what is a multi-dimensional array. So we can have a 1-dimensional, 2 or 3-dimensional, or more than 3-dimensional data structures using arrays. And I'm sure that everyone knows this concept. The data could be multidimensional due to multiple factors in that. We spoke about the image data to be 3-dimensional. We spoke about matrices to be 2-dimensional. Then we looked at some of the basic operations on these data sets. So quickly, I'm going to click on this topic, which is indexing and slicing in NumPy. Okay, so this is where we had left off yesterday. And before this, what we have done is basic operations, as you had seen. We had tried multiplying matrices. We tried taking out, different operations which we have done onto these matrices, like division, multiplication, etc. So yes, we also saw how to actually multiply a two-dimensional data structure with each other, provided they have the same shape and the dimensions. So so now we are very clear with what are shapes in these arrays. We are also very sure that what are the number of dimensions, or basically ndim, in these objects. Okay, so keeping that knowledge which we have received yesterday, keeping that in mind, let's proceed and let's look at the array once again so that we are able to apply different other operations like indexing and slicing. Okay, so what does an indexing do? So indexing is helping us to take out or select a subset of our data, or basically individual elements which we have. So far what we have seen is the various type of arrays, as you have seen now. And now we can look at how we can work with these arrays. So we have simply created arrays. So far, we have done multiplication of those arrays or any kind of an operation on those arrays. We have also tried changing the shape of those arrays. So let's see what we can do. So once we have created an array, we will definitely want to fetch data from it. And there are various ways to fetch data from an array. So we will be using an array slicing. So let's look at this part. So let's start with a one-dimensional array to be simplistic. So we have array 1 to 8, which has an index from 0 to 7. I hope everyone agrees to this one. So how do we create this one? Import numpy as np, and then we have np.array, and you give me 1, 2, 3, 4, all up till 8 observations. So the first element is marked with 0 and the last element is marked with 7. That is because of the 0 starting position. We can directly query a cell by specifying the index we want to select. So let's say you would like to have the index number 7 that needs to be retrieved. So as we have seen before, that if you want to retrieve anything in Python objects, you need to use a standing bracket. All right, so we're using standing bracket here, and I'm saying from my array object, which is ARR, you pick up index number 7, which is supposedly the position number 8, and the position number 8 is actually number 8. So when I try to retrieve by running this one, it says yes, 8 is the output which you have. What about the second position in my array, which is actually number 2? So when I say you give me the second position in my array, that is number 2. And that's how we are able to retrieve elements from the arrays. Now, these retrievals tend to become a little more complex when you start fetching data from multi-dimensional data sources. So let's say, what if you want to query a range of the arrays? Basically, fetch out a slice we can do by specifying an index range that is from start to stop, and we can give this range with the help of a colon which we have. You can see that we have a colon here. So the start refers to the start index, and the stop refers to the last index up to where we would like to fetch the data. So we have a one-dimensional array, and we would like to fetch data from it. So the previous commands which we saw was specifying a single range, not even a range, specifying a single position to retrieve the data. But now we can also specify the range. So let's see, how do we specify the range? So let's say this is the array. And then you would say, you give me the array from 2:5. Okay, so 2:5, it's actually 2, 3, 4, 5. Now, just I would like to remind you in Python what we had started before. When we try to slice any object in Python, and whatever range, the stop range which we define, you always supposed to do a -1 from that. So if you have 2:5, then you can drop, 5 means 5 minus 1 is going to be 4. So that's how we're going to get data up till 1, 2, 3, 4. That is 2, 3, 4, 5. It's going to be my values. You can see here, my array is 0, 1, 2. So you can see the starting position is 2, which is 0, 1, 2, which is number 3, and all up till 5. So 5 we are not considering. We are saying 5 minus 4, 5 minus 1, that is 4. And that's how we're going to consider all up till number 5. You can see that we have retrieved a new array called as 3, 4, 5, which is nothing but the slice of our array. And we have used the slicing using the colon. Right, so this is like, so values fetched are by reference. So let's see this. There is one more important concept that we need to understand. So the slice or fetched is not actually a new array, but it references the primary array. That means we have no new memory location for this one. So let's say you give me an array slice and this colon is equal to 25. So what does this mean? So this means that you start from, so here, let's go. So here we have, so array slice 2:5, and the array output is going to be 3, 4, 5 for us. And we are saying that you replace these 3, 4, 5, whatever values we have in index 2, 3, 4, you replace that with 25. So when you say array slice something is equal to 25, that's where it's going to replace. You can see this one. Correct. So how did this happen? So we are saying that you load this, range which we have 2:5, which is, which is this one, 2:5. You load this into another variable called as an array slice. And then I'm going to say array slice. What does this colon mean? Colon means that everything from the start and all up to the end. There is no limitation as such. You can start only from index number 2 or 6, anything. So start from wherever is the start and you go all up till the finish. So that means all the values which we have like 3, 4, 5, all will be replaced with number 25. And that's what you can see here in the image. So the array values which we had like 3, 4, 5, they all were converted to 25. So the final array looks like this. So what we saw is we can create an array, we can retrieve elements from the array, we can retrieve elements from the array and replace it back with the new ones. So we can see that the 3 corresponding values got set to 25. There's one more thing that we have to observe here is it is important to know that we made the change to the array slice, but the change also showed up inside the array. So we said that you change the array slice values to 25, that means 3, 4, 5. But when you actually look at array, which was the original array, even those values would change. So as we saw that Python is not creating a copy, Python is simply doing a reference. If we want to copy the sliced array into a new array, then we have to explicitly specify that you're wanting to copy this array and load it into a new variable. So let's say this is the original array which we have. And I'm saying you give me, the slice of this array from index number 2 all up till 5. So that means 0, 1, 2, starting from 3, it will go all up till 5 because 5 minus 1 is 4. So it's going to give values up till 5. I'm going to say you copy this, seek, the range which we have, explicit copy of the sliced array. And then you load that into an array slice variable, okay? And then you replace that all the values with 25. So you would see that our original array will still have the original values in this case, because we created a copy of the array slice and we did not actually do this in the original array. So the array slice is nothing but we created a new copy of the sliced array. And then when we checked with the original array is still the same, but the array slice is has changed to different values, as we have seen. So all values of 3, 4, 5 have now converted to 25. So as we can see, the elements with the array ARR variable did not change. The array slice, however, got updated with a value of 25. So we have to see that the copy function is literally creating a new array from the slice. And this operation could take a while if the array is large. Now, what we saw is a broadcasting. So what we did is array, you give us a range from 2:5, and you assign that to 25. This is one of the part of broadcasting. So this line is an example of a broadcasting. Over here, we can say that the value 25 is propagated to the entire selection. Even yesterday, we saw array broadcasting, right? So when the array has a missing equivalent shape, then it broadcasts itself to meet the shape of the, the other operand, so that the operation is successful. So broadcasting is very commonly used in several data operations. Python makes it really easy for us to change the values. So let's see, this is a 2D array. Now that we have said that one-dimensional array looks, let's see some operations, two-dimensional arrays. Okay, so these are the two-dimensional arrays. You can see that this is in a row and a columnar format. And we have got some numbering in the row format, and there are some indices to that. So we have got 0, actually M and N, where M is the row and N is the column. So the first one you can see, so 1, the base is 0 and 0. So the first number is actually a row, and the second one is a column. So you can say this is the 0th row and 0th column as far as indexes are concerned. This is the 0th row and the first column, and so on and so forth. And you can see the second one. This is the first row as an index and the 0 column. Correct. And you can see that array element, this is the M. So that's how we are able to see the array and create the index position. So let's see this one, np.array 1, 2, 3, 4, 5, 6, 7. So we've got a 3 by 4 array. So this is a two-dimensional array. And this is a 3 by 4 array. So what we're going to do with this? So let's see how we are going to fetch some elements from a two-dimensional array. So we need to use the row and column indexes to fetch a single element. It is important to remember that this is two-dimensional array is actually made of 3 independent arrays that have the cell values. Let's see this. So when I'm saying that you give me array of whatever object, you give me the first 0, that is the row, and then you give me the 3 is the column. So you give me the column over there. Now we need to understand this is a two-dimensional data, so that's the reason which we have to do this. Okay. So let's say we are saying that from my array 2D, you take out the first row and you give me the third index from the first row, and the third index from the first row is nothing but number 4, which is this one. We have successfully fetched row and column, so the cell value of 4 gets returned. Let us try to fetch an entire row. Can we fetch the entire row? Let's see. So array of 2D, this is the second row. Fetching second row data. So we can see that we fetched the slice of an entire row, and this row is actually at index 1. Let's look at three-dimensional arrays. How do you know that this is a three-dimensional array? We've got 3 brackets. starting with these objects. You can see this. So let us take a look at 3D array and some operations that we can perform. So everyone knows how to define a three-dimensional array, and that is what I have done. So this is going to be your one array, and this is the second one, this is the third, and this is the fourth one. So let's see, the three-dimensional array looks like this. So this is the three-dimensional array. This picture is nicely depicting how a three-dimensional array would look like. So you can see that it's actually holding two matrices of 2 by 3 shape each. And each of the matrices has an index of 0 and 1. So that means you will have to specify, three different, if you want to fetch a scalar value, you need to specify three different, positions of your index. But we'll see how we can do it. So the two arrays of shape, so we have about two arrays of shape 2 by 3. So that means if you look at the shape for this, it should come out to be 2, 2, 3. So if you look at the shape for this array, it comes out to be 2, 2, 3. Okay, so let's say extracting a 2D slice, how do we extract? So let us try to extract one of the two-dimensional arrays as a slice of the three-dimensional arrays. You can see that this is array position. This is the entire matrix with index position 0. This is the another matrix with index position 1. And we have both zeros and 1 into array 3D. So what we want to do, so let's do this. So array of 3D 0 is going to give us 1, 2, 3, 4, 5, 6, and array 3D of 1 is going to give us 7, 8, 9, 10, 11, 12. This is because we did not use the print statement. So I haven't created that array anyway, so I will have to create that array. So just installing numpy, I did not run the notebook from the scratch, from the start of the, so we will quickly install numpy. So I'm using a pip installation method. Okay, so no problem. I'm going to go and say restart. So kernel is restarting, kernel is ready. So what we can do is we can comment this one and uncomment import numpy, and we can create our 3D array here. Quickly, we created a 3D array. And what we want to do is to check the shape of this array, and you can see that it is 2, 2, 3. So how do you extract a 2D slice from a 3D? So see this one, okay? So you can see that the 0th position is actually the entire matrix. You can see 1, 2, 3, 4, 5, 6. And in the second one, we are extracting the second index of that matrix, which is nothing but the matrix itself, which is 7, 8, 9, and 10, 11, 12. We can see that array 3D 0 got us the row at index 0, and the 0 is actually a 2D array. And same goes with position number 1, which is nothing but a 2D array. So simple stuff. So let's say we want to copy this 2D array into a new variable called as vals. And we want to basically replace all the values with 31. Let's see what happens. So, okay, so array 3D. So, but what is there in array 3D? Let's see this. Okay, so this is the array 3D with us, and it is 3-dimensional indeed. We are saying you copy this zero part of array 3D. So zero part of array 3D is this one. So you copy this and put it into vals variable, and then you pick up add 3D 0, the first matrix, and replace all the values with 31. And indeed, it's going to happen, and it's not going to affect whether we have, if we make any changes in the vals variable, because it's actually a copy, so it's not going to affect even a single time. So array 3 0 position, we have 31, so you can see all the elements of that matrix has changed to 31. And if you look at our, simply the add 3D, which I'm printing, we have this 7, 8, 9, 10, 11, 12. So let me run this part. So add 3D is still got three-dimensional, 1, 2, and 3. It is still three-dimensional. The only difference is that when I created a copy for this, the add 3D did not have any effect, other than when I'm mentioning 31 as in the first matrix. So the first matrix value all got replaced with 31. So add 3D 0 vals, and I'm saying now you replace your first matrix with your vals, which we had previously extracted. So we simply did extraction of one pocket to another, and then using the same pocket to do the another one. Okay. Let me see. Do we have values created as a copy here? So we have vals. So I will recreate this array. So what is happening is my saving a copy of the first 2D array. So when I'm saving this copy, so vals is also becoming 3D 31, correct? So let me rerun this. So 1, 2, 3 is our first array, and then 7, 8, 9 is our second one. So let's confirm this. You can see 1, 2, 3 is our first one. Just confirm this array 3D. Yes, we have. And now we are saying that you create a copy of the first matrix and load it into vals. Okay. And we have loaded that into vals. And I want to check the value for vals. Yeah, now it is correct, because earlier it was showing 31, 31, 31. And now when we assign this one, that is this one back to this one, using the syntax array 3D 0 is equal to vals, and then you give me this one, which is we are getting our original 3D matrix back. So same thing. So by default, we get a view of the same primary array unless we use the copy function to create a new array. And in this case, we created a new copy. We replaced that with 31, and then we replaced that 31 back with the array, and then we finally restored our original array. So I hope that was clear. Let's go with some advanced operations. Let's see what are the advanced operations that we are doing. Yes, Rajiv has a question. Can we give an example on where we use 3D arrays? See, usually the image data is all three-dimensional. So we are using all three-dimensional arrays for computer vision tasks, like in Python OpenCV tasks. Python, the vision libraries which we have for the TensorFlow and the Keras. So these 3D arrays are very useful in that. So as yesterday we have seen that image has got 3 dimensions. So the third dimension is actually the color, that is RGB. So yes, so there are instances where we require to deal with 3-dimensional data. When we have a video files, when you have an image files, that's where you have more than 2 dimensions. So let's look at the advanced operations and see what happens. So what I'm going to say, array 3D 0, which is this one. And then I'm saying you give me 0, which is nothing but the first row. I hope everyone agrees to this. All right, so let's see how we do this. I want to create a 3-dimensional array, which looks like this. And I'm saying I want to fetch only the first array slice here, that is 1, 2, 3. So how I'm going to do is array of 3D, 0, which is like your first array, this one. And out of this, then the first element, which is 1, 2, 3, because it has a 0th position over there. So the above example shows how to fetch the first row of the 2-dimensional data from a 3-dimensional array. And once we have extracted this, we can do, anything we do after that operates, remains the same way in the 2D array. So if you load this into another variable, it is still going to be a 2-dimensional array. So I hope this is clear and very short and sweet. Indexing with slices. Okay, so let's see this. So let us start with the 2-dimensional array. Here we will try to use some advanced slicing operations. So np.array is, again, this is a 2-dimensional. You can see this is the output for our array. You can see that it has got 3 rows and 4 columns. Now let us pick up out the first 2 rows from the 2D array. So how do we do this? The first 2 rows picking up is, I'm saying that you give me from the start of the row, that is 0, and all up till 2. 2 means 2 minus 1, that is 1. So 0 to 1. So 0 to 1 is nothing but 1, 2, 3, 4, 5, and 5, 6, 7, 8. And that's how we slice this array. Slicing of array is very important. So you can read this expression as select the first 2 rows of this array object. We must become fully comfortable with the syntax and how it operates, because such slicing operations are extensively used in machine learning problems. We can also pass the slice ranges for each dimension. So let's say this is our 3x4 matrix, and our slice is that I'm saying in the row. So anything which is before the comma is row, anything which is after the comma is actually a column. I'm saying you give me first 2 rows, considering this one. So you give me these 2, and in the column, you give me from column number 1 all up till the last. So that means from 2, 2, 6, all up till 3, 4, 7, 8. You can see this. You can see how quickly we are able to select subsets out of our arrays. Even if the array is wanting to be 3-dimensional or 2-dimensional, still we are able to quickly finish and complete the slicing. Let's see this one. So I'm saying you give me the first row, first and the second row, and you give me all the values up till column number, from the first column basically. Okay, so 1 and 5 is going to be my answers. 1 and 5, you can see. Okay, so I hope this is clear. I don't have to read out this one, because this one is actually read from the start all up till 1. Here, you read from 1 all up till the last. So wherever you don't specify before or after the colon, that means you take it from the start or all up till the end. Let's look at some more examples. I'm creating a new 3x3 array. And I'm saying that you give me the third row, okay, which is index number 2, and you give me all the columns from that, okay, which is 7, 8, 9, which is same as array 2D. So those things are also going to work. Here, what are the things? You give me index number 2 all up till the last, and you give me all the columns, so 7, 8, 9, so still the same. So you can see that there are different ways to write the similar things. So this output and this output is going to be the same. Array 2D, you give me from second row, and in the last column, all up till basically. So I'm saying from the first column all up till 1, so 0 and 1. So that is 4 and 5. So you give me 4 and 5, which is 4 and 5. I hope things are becoming clear. How are we creating arrays? We created arrays yesterday, and today we are doing indexing and slicing on those arrays, which is interesting. So let's say array 2D, this is a new matrix. New means the same matrix, which is 3x3. And what is this? I'm saying you start from row number 2 all up till the last. Okay, the first says the same thing. You start from row number 2 all up till the last. Even if you don't put this 2, it's still going to be the up till the last one, but that's fine. I'm saying you give me from, sorry about this. I'm saying you give me from row number 2 all up till the last, which is 4, 5, 6, 7, 8, 9. And from the column perspective, you start from the first column, but you give me only up till the second column. So that means you give me 4, 5 as the answer here. You can see this. I hope everyone is clear with this one. Simple stuffs, right? So Boolean indexing. So let's look at what is a Boolean indexing in this. So let's say we have a text array here this time. So this is the first time that we're looking at a text array which holds textual data. So np.array, we've got some names out here, and then there is some data, and the data looks like it is 7 by 4. Okay, so this array is actually 7 by 4. Supreet is saying for slicing second column only, what is the code? So you can refer this one. So if you want to just put second column, you want to retrieve. So you would say, you know, that you give me 1, and this is going to be like you give me all rows. I can give you a hint. I can write the code for you, but I can give you a hint so that you can also write. So you would want to retrieve only the second column, that is 258 values from this 2-dimensional matrix. So what does this mean? That we need all the rows, because 258 all comes in the rows. We need all the rows, correct? But we need only the one column. Okay, so we simply need 1. So you can simply say 1. So we have colon comma 1. So colon comma 1 is going to give you the middle column, which is 258. So the colon, you can simply use colon. So the colon means all the rows, comma 1. So let me run this one. So data is equal to np.array, and we've got around 7 by 4 matrix. Okay, so let's see this one. So let us take 2 arrays. The name represents the name of the persons, whereas the data array corresponds to some activity done by the people. We have total 7 names inside the names array, and we have a row of data per person, thereby 7 rows of data inside the data array. This is the name array, you can see, and this is the data array. Now let's say that we want to fetch all the rows of data. That means all up till 1 to 25. But we want to fetch all the rows of data belonging to people with the name Amy. How quickly we could do this? The answer is to create an array of booleans by running a comparison operator. So let's say, so names is logically equal to Amy. Will return true or false. So wherever in the array we've got Amy as a name, is going to mark that as true, and rest of the places is going to mark as false. So the above code produces an array of booleans. The value is true and the condition is satisfied, and false otherwise. So let's see this. For the index that has true, the element will return, while for the false, the element will not be returned. Simple. So what we're saying, that wherever you have Amy as a name, that means wherever you have true, you return me all that data. So let's say Boolean array is equal to names, which is logically equal to Amy. Okay, so that means Boolean array has got a list of true, false with them. And we are saying simply the data Boolean array standing brackets, and you pick up only those values which have Amy, which have corresponding data for Amy. So you can see 5 and 25, which is this one. So this AMI is actually on the second position, right? So this one is the second position, and the AMI is at the last position. So which is actually what, 6 and 7. So which is the last position as this one. You can see the AMI at second row and AMI at seventh row, and both the data were picked up by, and we used a standing bracket. We did not use anything differently out here. You can see we simply substitute those values as a Boolean's collection, and then we pass that into the data. Let's say this one, as in fact, so using the Boolean index is same as querying directly by specifying the index. So we could have achieved the same step by simply providing the values here. So you can say the data is 1,6. That means you give me the second row and the last row, and which is no different than what we had done before. So if I run this, it's going to give the same output. This is also going to give the same output. So I'm going to say that from the data, you give me, the row should have all the values from 1 to 6, and the column should be all columns. You can see there's a colon, so you can definitely get all the values for the column and the rows. So the Boolean array must be of the same length as the array access it's indexing. So let us try some examples. So let's say data names is equal to AMI. So you can see this one. So in the rows, you give me only those rows for which the names are equal to AMI, which is like we saw what are those rows, 5 and 25 are the rows. That is the second and the last row. But I'm saying that you give me data from the second column all up till the last. You can see that, give me the rows with the names AMI. So we had only 5, 6, 7, 8, and 25, 26, 27, 28. And I'm saying now you start with column number 2, which is actually 3. So 0, 1, 2, this one. Yes, correct. All up till the last. So 7 and 8 is the value, and 27 and 28 is the value, which is this one. Clear, guys? I hope this is all going well. We've been creating arrays, and now we're just playing a bit with the arrays about slicing and dicing, replacing the values with new ones. More or less, this is indexing and slicing, which we are performing. Let's say this one. So the data names is not equal to AMI. So you give me those rows wherein the names are not equal to AMI. So that means it's going to skip the second and the last row for us, which it did indeed. Let's look at some of the multiple conditions. So data where names is equal to AMI or names is equal to will. So any of the names that you find out, you give me the output. So the moment we run this, the data could find AMI as names, and it just got retrieved that one, because once you find AMI, it won't go on to finding will. So let's set some values conditionally in the array. So we can also use indexes when setting values to an elements. All elements qualified with the Boolean condition will get the value set. Let us try to set all even numbers in our data array to 0. So let's say data is equal to, and what is the data? Data is nothing but our matrix. So this is the matrix, and we're saying data divided by 2, and data, so this will return the remainder for us. So let's say data divided by 2 and data divisor 2, which is going to give us the remainder. So 11 divided by 3 is going to give us remainder is 2. 10 divided by 2 remainder is actually 0. Okay, so let's see this. I'm saying in the data matrix, you divide all values by 2, And if the remainder is equal to 0, then you give that as 0. So you can see that all numbers which were even, so in fact, all the numbers which were even have now turned into zeros, and all the numbers which were odd are there in the matrix. So they're just left untouched. So quickly moving on to the last part, maybe for this notebook, that is fancy indexing. We'll quickly look at this part. So fancy indexing means passing an array of indices to access multiple array elements. So let's look at this array. ARR is np.array at this one. Suppose we want to access 3 different elements. We could do this by saying that array of give me 3 and 5 and 7, and that's how it's going to give us the 4, 6, 8. We could have done this differently also, but we can pass a single list of arrays to obtain the same. So let's say index is 3, 5, 7. This is the index for me. And when I run this, it's going to give us the corresponding indices values, which is 4, 6, 8, which had a position of 3, 4, 6, 8, which had a position of 3, 5, and 7. So when we use fancy indexing, the shape of the result reflects the shape of the index arrays rather than the shape of the array being indexed. So if you have passed the index in a form of a list, and that is what we've got the shape here. So let's say index is np.array 3, 7, 5. So this is going to retrieve matrice because the shape of the index was that of a matrix. Pretty simple stuff, right? What are negative indices? We can use negative index to count the index from the bottom of the array or from the last of the array. A value of -1 means the last index of the array, -2 means the second last, and so on and so forth. So if you have an array, so let me do the cell above and say ARR. This is our array. And we are saying that when you do -1, 2, and 3, then you give me 10, 9, 8. Let's quickly jump to on the lesson number 5, because we also have pandas, which we have to cover in a very short stipulated time. We'll try to see how far we are able to go on this part. So let's click on lesson number 5, that is universal functions. These functions, I may not run this notebook. We will quickly skim through this, guys, because we have another 1 hour wherein we have to, maybe less than 1 hour, wherein we have to finish these 3, 6, 7, 8 also. We'll try to stick to this as far as possible. So we have some universal functions which are divided into 2 parts. Which is a unary function and the binary function. Let's look at what a unary function. Unary function is simply the function which is returning single values to you, correct? So a unary function operates on a single matrix by itself, while a binary function requires 2 matrices. So let's see, unary function is np.square root. So the moment you do np.square root, it's going to give you the square root for all the elements of your matrix. np.exponent. Exponent is going to give you the exponents for all the matrices and all the element values which you have. np.logarithm is going to give you all the logs of all the elements which we have in the matrices. np.rint, rint stands for round to an integer. So if we have this array of 1.38, you can round it up to an integer which goes up to 1, 2, 3, 4, whatever values we have in this case. If the decimal is the 0.5, then it's going to round up to a higher number. And if it's less than 0.5, it's going to float it down to a lower number. What are the unary functions available in numpy? You've got absolute values, so you can convert negative to positives. Square roots, square, exponents, logarithms, sine, seal, floor, round of integer, mod f. Is nan is actually a Boolean function. Is infinite. We're going to use these ones. These are trigonometric functions. We are not looking at trigonometric functions, but yes, cos, sine, tan h is something which we can use. But We have not demonstrated any trigonometric function examples. If you're working on scientific project, definitely you would require some trigonometric library. What are binary functions? Let's start with two matrices. Perform some basic arithmetic operations. Okay, so we got two matrices A and B, and we want to do addition of A and B, which we can very well do. So it will add up element by element. Subtraction, no different. It will subtract element by element. Multiplication, no different. Multiply element by element. Division, element by element. You can see that if both the matrices are of same size and shape, we can very well do simple operations like addition, division, etc. So what are the binary functions available with us? Binary functions are add, subtract, multiply. Why we call that a binary functions? Because there is a need for two objects in this case, because I cannot add an object by itself. I can do that, but still that would not be reasonable. So I have to add I have to take more than one object to do this. And what are the other ones? So we have power, divide, maximum, mod, greater, logical, etc., etc. So quickly, we have seen universal functions. Similarly, we have statistical methods. So we do have statistical methods in NumPy. Let's see that. So NumPy provides several statistical functions. We use basic statistics in everyday life. So I'm going to quickly run through this because most of this thing we have already done in this. When it comes to statistical function, I'll just stop there and we'll try to elaborate. But in places where we have already done, I won't spend much time. Let's say here, I will not explain because we are creating a 4x4 matrix, a random number matrix. Out here you can see. So this is that I will still run this because we might need it in the bottom section. So NP is not defined because I have not installed NP. So the instance here is, you can see that whenever you install one of the instances, you need to reinstall that back. Okay, so when you open this notebook again, you will have to reinstall NumPy due to some reason. So data list, and here we have that data list with us. So let's say used to fetch summation of all values. So data underscore list dot sum. What is going to happen? It's going to pull up all the elements and it's going to add up all the elements and give us the values. And the addition of all the elements is coming to as 7.62. What is the mean? This is actually the arithmetic mean, not the weighted mean. Generally, we also consider weighted mean apart from arithmetic mean. So this mean says sum of all the terms divided by number of terms. So how do you get this? np.mean data underscore list, and you can see that it is giving us scalar value. Median is, again, as we know, that what does a median do? So when we go to data underscore list and we say median, you get us the median for that. Standard deviation is nothing but the observation minus the mu. What is the mu? Which is the mean of the data, the whole square divided by n and the square root of that. And this sigma is a Greek letter, which is for standard deviation. So if the standard deviation is low, means that most of the data points are close to the mean of the data. If high, then they are spread out. In reality, if you want a good model, then all the observations should be as close as to the mean. And that is what the aim for regression is, right? So the regression is like it starts to fight back, regress with its data till the time it reaches the closest point of the mean. Standard deviation, directly we have np.standard deviation, and you can specify the list. Not just metrics, you can specify anything for standard deviation. You can also specify a list. Variance. Okay, variance is another number which represents spreadness of data points. Its formula is square of standard deviation. So here we can see that here there is a 7.3% variance out here. Min and max, np.min, np.max. What is argmin and argmax? So let us say we want to find the index of the element with the min or max values. So simple np.argmax data underscore list is going to give us index for the maximum value over there. So we can say insert cell above. I'm going to say data underscore list. And what is the max value in this case? 9.92, which is this one. Actually, this got reset, but that's fine. So let's say 0.98, and it's going to give us the index for that, for the 0.98. Let's see what is the index for that. The index is 11. Okay, what is the index value for the minimum one? It's 13, index number length 13, so which is this one. What is a cum sum? Cum sum is a cumulative sum. You must have seen cumulative sum as the growing sum. Okay, so you take the sum of the previous observation and then move on, and then you keep adding the observation, the resultant observation of the previous value. So returns the cumulative sum taking first addition with 0. So np.cumulative sum data underscore list. So np.cumulative sum, we can see data underscore list is, you will see the number is, they'll keep increasing, they will not decrease. Cumulative product, the same as the cumulative sum, we have the cumulative product, which returns the cumulative product of the array, which takes the first product with 1. Okay. Some more common methods are, which we can see that we have sum, mean, median, standard deviation, cumulative sum. So this is cumulative product. So these are the representations for that. Let's go with array and set operation. So what is array and set operation? So np.unique returns the unique values of an array in sorted order. So let's say this is a fruit and there's some text values in the fruit. And when we say unique, it's going to drop all the repetitive values and it's going to give me only the unique values. Same goes as intersection. So let's say you have an array of fruits and the second array of vegetables. And when you do the intersection, it's going to give you only the common elements between both the sets. What is a union? Union is fetch elements present in both sets, a standard set union operation. So you can see union of 1D fruits and vegetables is going to actually combine both the arrays into one. The differences performs a difference between operations of the two sets. So when we take the difference of A and B, when we say the set difference between fruits and vegetables, then it's going to give us only the items which are not present. So as per the example, we get everything from set A, which is everything of fruits, but not in the veggies. All right, so you can see, I will have to run the entire code from the start, but that's fine. So set difference one, so we have fruits and veggies, it's going to give us the difference only what is not present in the veggies. Symmetric difference, get all the elements in both the sets except for the ones that are common between both the sets. So just get me those elements which are not common between both the sets. So set XOR, you can see. So we don't want the intersection. So don't get the elements which are not intersecting. And what are the commands for the set operations? We have unique, intersect 1D, union 1D, set difference 1D, and set XOR 1D, which we have already seen here. So pretty simple usage of numpy, right? So we saw indexing and slicing, which was one of the challenging things. Statistical methods are simple. And same goes for the linear algebra also. So the linear algebra is also nearly the same. So we have, so what is it? So in fact, the numpy's, the primary task is to deal with the algebraic numbers or basically calculus over there. And when you do algebraic equations, all the data is residing into the form of arrays. Guys, today we are, I hope everyone is with me on this page, and I hope I'm not running too fast. I hope the pace is okay with everyone, and at least we are able to cover up NumPy, from yesterday. And also we will be looking at some of the pandas things. Sorry, today I couldn't look at much of the questions. So Rushali is saying higher order. I'm just picking up the last one. So sorry guys, in case if I didn't take your questions. Rushali is saying higher order stat like kurtosis available. Yes, Rushali, it is available. Um, but that's a summary statistics which we're going to look at once we move forward. Once we have the data set with us, we will start doing those things. In fact, in pandas also we have a stat module which gives statistics for each and every variable which you have. Again, there's a question. I mean, higher order stats like kurtosis are available. Yes. Swapna, arg means indexed value. Yes, that's correct. Bobby is saying data list is a 2D array, then why argmin or argmax giving single index number? It should give something like, no, no, it's not going to do that, Bobby. See, because we are not returning, it's not returning a collection, it is returning a scalar value. Argmin means you give me a single scalar, which is the minimum value from the collection. And argmax is you give me a single value, which is the maximum in the collection. So when you say argmax is going to give you a single record, which is maximum value, and argmin, which is a single record with the minimum value. Abhishek Roy has a question. What is the D type is equal to less than U6? U6 is the Unicode characters part. D type is, you can look at the Python documentation for D types. But in this case, we are saying it's an unsigned integer Unicode 6, which we are defining out there in the D types. So yes, when you define arrays, you also have a flexibility to define the D type. In fact, you can say this one. So NP intersect, so there's a one way that if you really want to check there's an error in this, let me refresh this part. So we'll load the kernel. I mean, I'll come back to this D type. I have to put some, I have to throw some insights on that, the less than U8 one, but let this reload. I'll come back to that. So as you know that in NumPy, apart from statistics, it is meant for linear algebra. Guys, just give me one moment here. So linear algebra is all about matrices and determinants. Um, and in fact, machine learning is all about matrices, um, and of course, regression. So linear algebra gives us it basically works on matrices. So NumPy provides us a complete range of functions that we can use in linear algebra. We are required to perform several linear algebra operations when working on data. So NumPy has a dot function which returns the dot product of matrices. A dot product is a matrix multiplication operation. Let's look at this one. So np.array, you can see it's a two-dimensional array. So this is matrix one. You can see this is matrix one and this is matrix two. And I'm saying you give me the np.dot of mat1 with mat2. So what it's going to do, it's going to give us a dot product. So dot product means it's going to be a multiplication. So you can see. So this is the first array. I'm saying you dot mat1 with mat2, and you can check the output. So 67. So you know what does a dot product do, right? It does a matrix multiplication with that. So we have 67, 44, 52. You know how two matrices are multiplied, right? So this is not a one-to-one multiplication that 23 into 1 and 3 into 2. It's not like that. It's actually 23 into 1 and into 7 and 4. The typical matrix multiplication which we have, which we use it through the pen and the paper, which we've been doing in the elementary mathematical classes. That is the dot product between the two matrices. And if you try to do that, you're going to end up with 67 and 245 and 232, which you can try to do that. You have to multiply the first element with all the elements of this matrix and then take up the sum of that so that it may give you all these values. So this is a simple dot operation between matrix 1 and matrix 2. So we can see the result matrix is the multiplication of the two matrices. NumPy comes with a dedicated package called linalg, which stands for linear algebra. And so let's take a look at some of the functions from this one. From NumPy, import linalg. Okay. Commonly used functions are diag. Diag is actually the diagonal of the matrices. Returns the principal diagonal of the matrix. So np.diag of matrix 1, you give us 169, which is this one. And 169 is 1 plus 6 plus 9 is equal to 16. And this is how we're going to do the dot product also. So the dot product will take a value from one matrix, multiply with the other one, add it up, and then give the result. So we can also use trace in this. So you can see 169 needs to be 16. So you can see np.trace is 16. Correct? That's basically the matrix operation. What is a determinant? So there are some calculations done here. Returns the determinant of a matrix. I'm saying lin algebra, give me the determinant of the matrix, and usually the determinants are happening through 1 into 6 into 9 minus 8 into 5 plus 2 into 7 into 5 into 4, 7 into 9 plus 3 into 6 into 4 and 7 into 4. You can see this. Same things are happening on the dot product also between two matrices. Same operations we had performed. And it gives us the determinant of a matrix. So what are eigenvalues? So eigenvalues and eigenvectors of the matrix. I mean, if you talk from, in a common word, what the eigen does. So let's say you have a matrix. What is the most reasonable value for that matrix in a form of a scalar? I mean, see, a number, when I say that this is number 10 and this is number 20, we are able to quantify both numbers because 20 is higher than 10 and you can quickly recognize that, right? But what if you have matrix with you? How would you recognize what is the most reasonable answer to this matrix or one single number for this matrix, and that is eigenvalues. So we're going to say linalg dot eigen of matrix 1, whatever the matrix 1 I have, and you can see that these are basically my eigenvalues. So I'm going to insert cell above. I'm going to say at 1. I'm not sure if I've loaded this one. Yes, it's there. So what is the eigenvalue for these matrices? For this is the matrix, and these are the eigenvalues there. Eigenvalues and eigenvectors, they both are used heavily for dimensionality reduction techniques. What is an inverse of a matrix? Inverse of a matrix is nothing but the inverse of a matrix. You can see, and what is the formula for inverse of a matrix is this one. A inverse 1 is equal to 1 upon mod of A is like you give me all the positive values. Okay, so inverse of matrix 1 is this one. Pseudo inverse. Pseudo inverse is like used to calculate inverse of a matrix using single value decomposition. Pseudo inverse we have used. Now, these things are very much required for machine learning, guys. What is QR decomposition? Decomposing a single matrix into two Q and R matrix. R is an orthogonal matrix, and sorry, Q is an orthogonal matrix, R is an upper triangular matrix. So QR decomposition of matrix 1, linalg is not defined, that's fine. So I can say cell above from numpy 4. And print Q and print R in this case. You can see that we have the outputs. But that's fine. We can, what is a singular value decomposition? In SVD, a matrix is decomposed into 3 different matrices. It's like unpacking a tuple, correct? Where U is a unitary array, S is a vector array, and V is a unitary array again. VH is a unitary array. So you can see the way we unpacked the tuples, similarly, we are unpacking the matrix into 3 different objects. And it's going to print U as U is a unitary array, S is a vector array containing eigenvalues, and VH is a unitary array again. So when we're going to print this, the usefulness of this one may not be, very much evident right now. But yes, as we move forward, you will realize that we're going to use all these things for optimization. Solve. The solve function is used to solve a linear matrix equation AX is equal to B, where matrix A and matrix B are known and the matrix X needs to be found out. Or one can also say that the equation is to be solved to find X such that AX is equal to B is satisfied. And this is what we've been doing always in linear equations. We've been trying to satisfy both the sides, LHS or RHS, in any of these scenarios. So solve matrix 1. So linear algebra provides several ready-to-use functions. We can find the complete list of such functions on this website, that is numpy.org. When you click on that, it's going to give you all the available Swapna and solutions team, please explain a dot again. So as I said, dot matrix is multiplying, deriving a new matrix by multiplying 2 matrices, correct? And how have you been multiplying matrices? I mean, we've been studying that. The way we've been doing that in basic mathematics, how to multiply 2 matrices, that is just a dot product. That is a dot product. So if you pull up any example on internet to multiply 2 matrix manually, you can pull up any mathematic matrice, reference, and you can check how are you multiplying or adding basically 2 matrices. And we are not talking about adding, but yes, multiplication. So when you're multiplying 2 matrix, there is a method to do that the way we saw for the determinants, right? And simply it is a product of 2 matrix. This one is a very simple lesson, I guess, which we can finish in just a few minutes. So when we load arrays, sometimes it is important for your work to export the work which you have done in the form of arrays. Let's say you have created some arrays and you would like to export those arrays for whatever reason. So let's say you have created an array numpy a range 10, and this is the array. You would like to save this array. So you will say np.save and you'll say my underscore array and give you the name of that original array. So the arguments here are first give the name of the new object and then provide the original object. Okay. So the above line saves the entire array to a file name. So we're going to save this np.save, run this, save my array with a name called as my array. So do we have anything which is being saved here? Can you see this? In fact, it is saved, but it did not save right now. So let's see if we can save it right now because I did not put that any. So the above line code saves the entire array to a file name my array, and the file is created in the same location where this Python program is running. The file location in other terms can be described as ./my array. Okay, so I'll have to refresh this. I don't see my array loaded here. So how do you load this? So let's say you have saved this my array. Let's say this is the array which is being saved. Okay, so this is there. Yeah. So a minute ago, can you see this? So a minute ago, we saved this one, my underscore array dot npy. Npy stands for numpy. So I have saved this array. Now I want to reload this array. I'm going to say np.load my array.npy, and that's how it's going to load the array back. How do you save multiple arrays? Saving multiple arrays is like you have one array, array number 2, np.save_z, my arrays, wherein A is array 1 and B is array 2. Let's see, does this work? Okay, it did work. And let's refresh this. So here it's going to come my underscore arrays underscore npz. Okay, until that loads, so we'll proceed. So what is this save z is going to do? It's going to load these two different arrays into a single one, and we can later on uncompress it. So we use different function. We are using save z instead of save. So the save z function creates an uncompressed archive of the arrays. Can you see this one? A minute ago. And when you click here, that's fine. You would give it, you're saving the C console. That's fine. So this is like, it says it's not UTF encoded. Maybe because I'm not running this from the scratch, I will have to run this all from the scratch, but that's fine. So we can save the object here and we can retrieve the number of arrays which we have in those objects. The way we save it, we can also load it. So you can say np.load my arrays npz. This will actually, so the extension of the save file npz instead of previous npy. So the load method loads both the arrays in this case. So when you load this array, you can load it into your first one, that is your A, and the second one, that is B. And when you print it, it's going to give you, it's basically like splitting and then getting it back. You can also compress. So let's say if your arrays are really of large volume, which typically are the cases in reality. So np.save_z compressed my arrays and array A and array B. Arrays np.load, you load my arrays.npz, you load into first, second, and you give us the arrays. So this is like, how do you handle arrays from the files perspective? And this is what we have done in this arrays in files. So you can see how NumPy is so mature in order to handle these kind of operations, be it matrix multiplication or any kind of a calculation which you'd want to do. It also provides you flexible way of storing and retrieving of these arrays in the form of dimensions, in the form of shapes. You can change the shape of NumPy arrays into the desired shape which you like. Always ensure that when you multiply matrices, they should be of the same shape and size. Couple of other things that we can perform linear algebra, but there's more to that, in fact, in NumPy, which we will be looking at as we move on to the machine learning class. So I hope this NumPy session was not too fast for you. I hope we could cover adequately what we wanted to. And the further to NumPy, which we're going to do, is all that's going to happen in the machine learning class. So any questions before we move on to our next topic for today, that is Pandas. And Pandas is going to be a little simpler than NumPy because it is actually dealing with textual or maybe a data frame kind of a data, which seems to be more realistic than numbers, which we see here. Okay, so I'll just close the kernels for these files. And then we're going to go to our Pandas, okay, which is this one. Okay, guys, so I've changed my notes from NumPy to Pandas. You can see that we have around 3 or 4 different chapters which we can finish in this. We'll try to be as quick as we can in this, but the idea here is to understand this part. Now, when we left off from NumPy, we have actually left the numerical calculation somewhere at the bottom. And when we talk about Pandas, it is typically used for data analysis and data manipulation library, which is built on top of Python. Now, since it is built on top of Python, it is tightly integrated with Python so that we can do all sorts of data analysis. Pandas also comes with its own visualization library, wherein you can analyze or do exploratory data analysis to some level. But yes, this library is not strong and as robust as Seaborn or Matplotlib or maybe the ggplot for that matter. But yes, Pandas are very powerful when it comes to qualitative data handling part. All right. So we'll be looking at how Pandas is going to help us. Okay, so let's start with the first chapter, that is Introduction to Pandas. And Pandas helps in deal with qualitative information. So it can have database tables, it can have Excel files, it can have CSV. So this is where the main data part which people usually look for in the trainings. They keep asking, when are we going to import a data file? And this is where the module is, wherein we're going to uh, import different kinds of data sets. So why to use Pandas? We have used Excel sheets, and sometimes it's tough to get what we want out of it. Um, in simplicity, you can say that Pandas is given you as a free open source tool to do data manipulation and data analysis. Even Excel will have some limitations that Pandas will not have. So you can access cell level information all up till axis level information. You can define your rows and the columns. Everything can do that. But why do we do this? Firstly, we might want to find a specific row or find rows with NA or missing values, and it can get very challenging to perform some of these operations in Excel document. See, a spreadsheet document is only good when you want to analyze information. Spreadsheet is not good when you want to transform the information, correct? So if you have NAs in your Excel document, it is very difficult to get rid of those NAs and assign reasonable values to that. But yes, in Pandas, we can do it. In many scenarios, real world data is large. It can span from few GBs to few terabytes. Excel works on small data, is not designed for handling very large data set. But Pandas, is it capable? Yes, Pandas is capable to handle really large data. Pandas name is derived from the word panel data. It's an open source library which is written in C and Python. It allows users to play with data very easily. What are the features of Pandas? So some of the features includes data analysis, data cleaning, and visualization. It also contains tools for reading and writing data in different file formats. So you can read the files in different formats, and you can also place it in it. So let's say you can read a file in HDFS format. You can, and then you can process the file and store it back into the HDFS. You can read the file from a text file, or maybe from a database table, and then process it and save it back into the database table. So those things you can do very well in Pandas, and Pandas is very fast. Let me see if I have installed Pandas. It's all installed, so we will not run this one. So for people, those who want to install Pandas and due to any reason you are unable to import it, please use the pip install Pandas to update this one. Now, Pandas is defined with basically three data structures. The first one is a series, which is nothing but the collection of vector elements like a vector. Data frames, which is nothing but the collection of series, and index objects, which comprises of series and data frames together. So let's look at what is a series. Series is a data structure. It is not an array. It is not a list. Though array and list are data structures, but series is another data structure of Pandas. The only thing is, a series is one-dimensional array like object having sequence of values. It comes with an associated array of data labels called index. So let's create a series. And after importing Pandas as PD, you have a method directly called as series here. So you can directly use this. I've run that part and it has completely running. And you can see when I try to output this, there is an index also. So the first column is for index and second column shows values. By the way, Pandas is also very good in handling label data. So if you have qualitative data which needs to be handled from the name perspective, Pandas is very good in that. In fact, Pandas was designed to handle label data manipulations. So this is a series. A series is a straightforward. You can see it is like a vector, but it's not a vector. But it is simply a collection of elements. And the other part is it has got indices. So you can actually call a series by the index number. The second data structure is a data frame. Now, data frame and pandas are like two-dimensional structures. The way we store the data inside a database table, that is also rows and columns. So SQL table and SQL database table is also a two-dimensional data structure. You can also say that they are data frames. So we represent two-dimensional data with a single data frame. So let's start by defining a data frame. So this is the data frame. And if you see, this is a dictionary, and I'm passing values in this as a list in the dictionaries. So when I create this dictionary with some name and the age and the department, you can see that we have this data here. So the data object we created is a pandas data frame. So the columns in our data is name, age, and department. There is an extra index that is displayed, you can see, which is the row index, and it is created by pandas by so you can see how nicely this table is created with the help of pandas data frame. So what first we did is we created a dictionary, because the keys for the dictionary acts like a column name for a data frame. And once the dictionary was created, we converted that into a data frame format, and that's how we got our data. Loading data frame from a file. So we have example.csv. Do we have it here? Yes. And what are the values in example.csv? So you can see these are the values for our data frame: name, age, department, role, phone number, and the email. They are comma separated values, and we would like to pick this particular file example.csv by using our pandas. When you say import pandas as PD, you have different methods like pd.dataframe, pd.read csv. So here also we're going to do pd.read underscore csv. And we are saying that you give me example.csv, which is already present in the working directory. If this example file would not be present in the working directory, then you would have to specify the absolute path to your example file. And when you run this, and this is what the file we have. We already have a file called example CSV placed in the appropriate folder. So this is how we could load the file. But there are delimiters that we can use. So in fact, you can see that you can say insert and insert cell above. I can say pd.read. You can see that there are various options that you are going to get in this. Yes, you can very well pull the data from the JSON. That is correct. We can pull the data from JSON. Can you see there's a method here, read underscore JSON, and read underscore. So yes, there are methods available to do the same. But right now we are doing CSV. You can also do in Excel. You can also do HTML and JSON and what other things. Because there's a question there, why the numbers are coming in exponential? Which number? There's a phone number you're saying, because it's a very large number according to Python. We can get it formatted, shouldn't be a problem. So when this data frame got read into this, it got read from a CSV file, and you can see the row number 17 is actually not a number. It's all NaN. Let's say if you want to specify the delimiter here. So let's say instead of read underscore CSV, going to use a read underscore table wherein the delimiter is comma. So let's use this. You can see this, it got loaded and we specified that the delimiter is comma. In case if you have any other delimiters like, the pipe operators, or maybe the question mark, or maybe the dash or hyphen. So in case if you have any delimiters with you, like comma or question mark or pipe operators, let's say you are scraping data from Wikipedia. When you scrape data from Wikipedia, there's unwanted characters which do come. You can clean that, or when you bring in the data, the space which we have between words is occupied by some special character or something. So you can use delimiters to specify. This is just like Excel, no different. Write data frame to a file. So we are creating a data frame called as data, and we are writing this data to a CSV called as data.csv. Index is equal to false means that I don't want a special row for indices in my output file. And I'm going to run this part, and it's going to load this data.csv into our repository here. So I just have to refresh this. That's right, Srinivasa. Phone number needs to be converted to a number. So you can see pd.dataframe, there's an issue. PD is not defined. I'm not sure why it needs the PD again and again. So I'm going to say maybe because I restarted the kernel. So that could be the reason. So let's see if Pandas is installed. Yes, it is installed, and I'm going to run this, and it has given this file here. You can see now a few seconds ago, and this is what we have. Correct. And that is what we loaded, all this Adam, Amin, and Rose and Mary. And we could very well load this into a data.csv, which looks like this. Yes, definitely. Aparna has a good question. Can we have a named indices instead? In fact, as I said, that Pandas is typically used for handling label data. Okay, so yes, so we can have named indices. In fact, moving forward, we're going to see that. Okay, so let's go to chapter number 2, which is a series, and it is a small chapter. The third one is going to be a bigger one, but that's fine. So let's go to chapter number 2. And as I said in the start of the lecture, that Pandas is divided into 2 parts, in fact 3, right? So one is a series, second is a data frame object. Correct? I mean, these are the 2 main data structures in Pandas, and the first one we're going to look at is series. And as we have said, the series is nothing but it's a single one-dimensional array. And the collection of one-dimensional array is eventually forming a data frame. So a series is one-dimensional array. It can hold any data supported Python. The labels associated with the series are called the index of a series. You can see this one as a row, a cell, and a column. So here in Pandas, we refer columns as attributes, and a single column is a series of any type of data. Okay, so any single column of a data frame is called as a series, but not necessary that you have to slice the series from a column of a data frame in order to create a series. You can first create the series and you can bind them together to form a data frame. So let's see this one. Import pandas as PD, and we have pd.series. So this is the series. And if you see the type of this, it's actually a panda series. The way we had numpy nd array, similarly we had a type. We have a type here called as series. And in series also, the indexes are automatically assigned to the series part. Maybe I think it requires the import part, not sure, but let's see. But it's still running. It shouldn't be taking such a long time. When this series object, which is this one, is created, you can see the indices are already there. 0, 1, 2, 3, 4, 5. Okay, successfully done, and we can run this. And you will see that the type of this series is it's a pandas data frame series. So when we see the output, it looks like this. It's still running, but that's fine. So it will create the series for no. So you can see the type of this series is pandas core series. And you had seen that the type was also different in numpy array, which was nd array. The type was different in your arrays. So this is all as different data structures. And we can simply print the output of series here. Let's count the number of rows in this series. So the number of rows in series dot count is 6. So index and value in this series. So let's say the way we had in the dictionary.keys, dictionary.values. Similarly, we have series.values, you can see. By default, indexes in pandas starts from 0, as exactly it would in other items. However, pandas makes it possible to have custom named indices. So let's take a look at how values and indexes match to each other in a pandas. So let's say these are the values. So these are the series values. And these are the series indices. Can you see the indexes all starts from 0 to 6 here? Actually, these are 6 observations. So we can see that the pandas has defined the index for us automatically. The moment the series were created, the values were given, the index were created automatically, wherein the 0 is the start and 6 is the stop with a step size of 1. Okay, so you can see the series creates and we can create indices. Coming to the one of the questions asked by the person, that can we give series other than numbers? So yes, this is an example. So pd.series 4351 and the index is DCEA. You can run this one and you can see that we have the indices as DCEA. So what would be the indices for this series? Simple series.index is going to give you those indexes. You can retrieve elements based on those index values. So index of E is going to give you number 5. So Panda allows us to specify an index range similar to how it would work in NumPy arrays. So you can see the series 1:3. So what 1:3 is going to give us? You start from position number 2, correct? Start from position number 2, which is 3, and you give me only up till 2, which is 3, 0, 1, 2, which is 5. Give me up to, so give me only C and E, which is 3 and 5. Simple stuffs, right? Filtering, we can use Boolean indexing concepts in like NumPy to filter. So this is a series. And now we are saying from this series, you use a stand bracket to retrieve, correct? That's what we've been doing to retrieve elements from object. So you can see series standing bracket. I'm saying you retrieve all the elements which are less than or equal to 3. Pretty straightforward, right, guys? So we have series standing bracket. We are saying series less than or equal to 3. You give me all those values which are actually less than or equal to 3. Filtering is one of the most useful method as it allows us to filter elements from a data column. It is often used to find data outliers. So for example, if we have an age column and someone's age in the database is written as 201, which seems to be not possible, so we can quickly filter it out and find out potential data issues. Some mathematical functions. So can we have series directly multiplied with another number element by element? Yes, that is possible. So it's not like this, like a list that you do series into 5 and it's going to repeat your series 5 times. No, it's going to actually multiply element by element by preserving the indices which you had presented before. You can see this DCEA is now within the values. So import numpy as np dot square root of series. So you can see it's going to give you element wise square root. There are several functions available. Some commonly used functions are various operations one can perform. So series multiply series by a given value, divide series by a given value. You can see we can add, we can subtract, we can take the square root, just like numpy, we can take the exponential, we can take the minimum and maximum, just like argmax and argmin. Series as ordered dictionary. So let's say a series can also be referred as a fixed length ordered dictionary. We can check whether a particular index is present or not. These operations on series are similar to how we could perform operations on dictionary objects. So let's say A in series, whether A as an index is present in series or not. And the the answer here is yes. You can see if A is in series, true. If X is in series, it's false. So the value to check for A and X are the index labels because D, C, E, A are index labels. The operation will return a true if a row with label A is present, and if it's going to return false otherwise. How do you create series from a dictionary? So you can see this is a dictionary with single element in that. And how do you create series out of this? So I've got this one. And then I've got series 1. And then this one. So you can see that we have actually created a series using a dictionary, and all the dictionary keys were converted into indices, and all the values were given as values. So we can manually specify the index keys just like this also. So fruits as this is the key. The P of dictionary is this one, you can see. And series 2 is nothing but pd dot series. You give me the pdict, index is fruits. And when we do this, we are unable to assign any custom index series, whatever. So I think the series object we are not found. Fruits is not defined. I have to define the fruits. Not sure why it's taking so long to run this notebook. Okay, and this is what we have. So the series 2 is defined. And when we get the output of series 2, you can see that we've got this one. But why couldn't we get the value for pineapple? Because pineapple was in there in the fruits, correct? So you can see. So when we are saying in the series 2 in the predict, so pineapple wasn't there in predict. Can you see there is no pineapple here? Rest all the other fruits are there. So pineapple is not there. Missing value detection. How do you detect missing values from your series? Simply, so as we know, our series has a missing value. So we're going to put a method called as pd.isNull series 2, and you can see that true. It has come out to be true. That means yes, there is a null value. This is one way of writing syntax. One way of finding the NA, and this is another way. Another way to find NA. So either you can go pd.isNull or series2.isNull. Both are going to return the same results. So we can also fetch the counter number of missing or NA values. So series2.isNull.sum. Give me the, actually should have been the count, but that's fine. So it's going to give you the sum. So it's we say that, okay, there are like one null values available. We also have not null function. So how does that work? pd.notNull series. So you can see the rest of all are true and the pineapple is false. How do you merge series? How do you merge series? Like this. So English pd.series, I've got like 4 indices to that. And in the biology, I've got 3 indices. And in the physics, I've got only 1 index. Now, guys, this example is interesting. We can look at this. We want to find the total score of each student. Okay, so let's start by totaling the score. In fact, what is the problem statement? Let's take up this scenario. We have scores of students from 1 mandatory subject and 1 elective subject. The English subject is mandatory for all students, and they must choose an elective between biology and physics. So that means English has got all the students. Biology and physics may have some of the students who are working in English. So we have Brittany who opted for physics and hence did not appear for the biology, while all others opted for biology and did not appear for the physics exam. So what we want to find is the total score for each student. Let us start by totaling the score of English and biology. So when you say English and biology, so wherever you could find the relevant index, it could add up, but Brittany could not find up. So there is a NaN value over there because we couldn't add it up because the key is missing. So as we can see, the common key got added, but the value for NaN because Brittany is not present. Brittany key is not present. So Pandas will substitute an NaN value if a particular key is not present. What if we try to add all 3? So all 3 will have NaN because no keys are present, right? So you can see that English plus biology plus physics have got actually no keys. So there we go. We landed up with all values as NA as none of the keys are present in all the 3 series. So how should we go about this one? So let's see. We're going to create a new variable electives and we're saying biology dot append physics. Okay, so when we say electives, so this I will have to run, and we are saying in electives you create a 4th variable called as electives and you append physics with the biology. So you had 76, 94, 45, and then 76 out here. And now you can say total English plus electives. So you can see this is what we have. And that's the answer we have. So we have the total scores for all the students, you can see. And that is what we wanted. But what we want to find is their average percentage marks. And we do this is by dividing by the series by number 2. So total divided by 2. And this is how we have. So we have 68 for Brittany and 88 for Tom and so on and so forth. Simple stuff. It will just require a little reasoning and little logic. Using the name attribute, so you can actually say CD1. I'm not sure what is there in CD1. So you can. This is the CD1. and I'm saying dot name fruit rates, index dot name is price. You can see this. So what is the name of this series? Simply give the name to this series. And this is simply put price. You can see the price column name is here, which is the index name. So this is the name for the series, and this is the name for the index. You can see the price is given. The name for the series is fruit rates. So run this, run this, run this. You can see that we have successfully named the series and also independently named the index. So you can name the index by saying whatever object dot index dot name, and you can name the object by saying the object dot name is equal to something. So guys, I hope this series chapter was good enough to work on. It's very simple, as you saw. There's no complicated, so I did not spend a lot of time in elaboration of these because they are straightforward concepts. The next part is data frame and index objects, which we're going to continue after the break. And after the break, we're going to spend good time on data frames. And we have a comprehensive lecture book here to work on data frames. And post that, some of the essential things in data frames in Pandas. So anything that you have, any questions you can ask before we go on a break.
Thank you so much, Suvir, for that. Thank you, everyone, for joining us on a Sunday morning. I hope it was a lovely session. We did numpy, and we've done data frames with pandas. We basically started with pandas, and pandas is a very, very important concept in the long run that you will use when it goes to Python. So let's take a quick lunch break. We'll be back again at 2 p.m. to resume the session on pandas, and we should be able to complete pandas today itself. And then before 4 p.m., just before that, we will be announcing the winners of the 7 Days to Data Science Challenge. So I hope you all are super excited. All of you have submitted entries. Our jury panel is still going crazy. They're still evaluating the results. So even I don't know at the moment on who the winners are. It's really, really crazy. A lot of entries and a lot of good entries, right? I must say it's really, really good submissions. So let's stay put. Hopefully we will be done by 4 p.m. It's really tight to make sure we evaluate everything that came in by yesterday night, 12 o'clock before 4 p.m. today, but we will be doing our best. So let's take a quick lunch break and continue again with pandas. And thank you to all of you. I actually saw that my team notified that some of you actually purchased the t-shirts. So thank you very much for purchasing those t-shirts. This is the same t-shirt as you see here, the one that I'm wearing, which is BlobCity, that says Data Revolution is coming. And you should have the link in the chat. So if you're not bought it yet, you can go ahead and purchase it. So it'll ship to you. We ship it in 5 days, but it's a little crazy. Sometimes even Amazon right now is not taking delivery of essentials. So shipping might be delayed, but you will receive it. So thank you once again to all of you who've actually bought the t-shirt. So congratulations for grabbing the t-shirt. And let's take a quick lunch break, and we'll see you again at 2 o'clock in the session. Bye-bye till then.